everybody able to get these ones done? Excellent. So this is our new unit on linear relations. The stuff that we did over the last 2 days getting used to graphing. We do lots of graphing and figuring out relationships in patterns. I think you're going to like this unit. Okay? Couple of things. Could you draw figure 5? Yes. Okay? I'd like to see you draw figure 5 and figure 6 in this one. And then in words, describe what's happening in the pattern. How would you describe how the pattern changes? So, did you notice as you went from figure 1 to figure 2 that all you added was 3 squares? And then, oh, look at this fancy. And then the next one, you had this one, and then you added 3 more. And the next one, you had
1, 2, 3.
this, and add this, and added 3 more. So for figure 5, did you get, you'd have this one, and then this one, and then this one, and then that one. We could label that as figure 5. And if I really want to cheat with the smart board, whoa. There we go. And that would be figure 6. So how do we describe what happens?
Every time the figure goes up, every time the figure changes, it goes up by 1.
Every time the figure goes up by 1, right? Figure 3, figure 4. Every time the figure goes up by 1, what happens?
It gets longer.
But how?
By 3 blocks.
You add 3 blocks. Where? All right. You add 3 blocks to the top right. That's a pretty good explanation, but if we did an activity where one person was drawing it and the other person just could use words, I don't know if I'd be able to draw it if you just told me that.
What if that person was a bad drawer?
You make up your own pattern and then have to describe it. It's actually writing a description where the other person can't see is pretty hard. Okay, this is a pretty good description, but what happens if it says you add 3 blocks to the top right? So here's my starting one. Could I add 3 blocks like that? Yeah. Right? How do I know I have to add 3 blocks in boomerang shape? And well, it's an upside down L shape or backwards. Like, it's complicated if you really want to describe it really clearly. It's like, how do you describe it? 3 blocks touching, with 2 blocks touching the previous block and the other one touching those. Like, it's just gets hard. Okay. Now we get to count the blocks. Okay. We can go through figure 1, figure 2, figure 3, figure 4, figure 5, and we can count how many blocks or how many squares are in each one. Okay? If you get done this quickly, I want to see if you can figure out a way to do 10 and 100. That's the challenge. How many are there going to be if you did 10 and if you did 100? So this would be skip a few, get to 10, skip a few, and get to 100. I hope you don't draw it out for 100. You'll be drawing boxes forever.
Literally a book. It's a book.
All right, figure 1 has 1 squares, figure 2, 4 squares, then 7 squares, then 10 squares, then 13 squares. What do you notice in the squares column in between each one? You're going up by 3s, which is what we explained in words, right? We said you add 3 blocks every time. We can see it in the numbers. We go plus 3. Plus 3, plus 3, plus 3. How many times did you add 3 when you got to the 5th one? 4 times. What is 4 times 3? 12. Why is this answer 13? You started off with 1, right? If we go back to our picture from before, here's figure 1, 2, here's figure 5. We have the green part is 4 times 3 equals 12 of them. And the blue part is 1 more. So can you see that for the 5th one, we added 3 4 times. 4 times 3 is 12. Plus 1 gives us 13. To the 10th one, how many times would you add 3? If the 5th one you've added 3 4 times, the 4th one you've added 3 3 times, the 6th one you would have added 3 5 times. When you get to the 10th one, how many times would you have added 3? 9 times. What is 9 times 3? Okay. 27 plus the 1 at the beginning. 10 should be 28. I should actually do 101, but I'll do 100. For 100, how many times would you have added 3? 99 times. So if we do 3 times 99 and add 1 more, 290. Good, you got your calculator out. 298. So one of the things that we're going to do with these relations, and this is called a linear relation because each time you go up by the same amount, if you drew these points on a graph, I could do that right now. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, comma 1. So I can put the figure down here and the squares over here. And when we practice with our graphing, 1, comma 1 would be right there. The next one is 2, comma 4. 2, comma 4. Then 3, comma 7. Then 4, comma 10. And notice, well, my graphing isn't the best, but they do make a straight, perfectly straight line. If I had perfect grid paper, right, and I could label perfectly, which obviously I can't, they'll form a perfectly straight line. And that's why they're called a linear relation. Linear means it makes a line. Relationship is when you compare two things. When we compare the figures to the squares, that's a relationship. And so anytime you're adding by the same amount, it makes the same equation. Now, you also figured out the formula without even knowing it. The number of squares, so if we say squares are equal to, what always happens is we did 1 less than the number times by 3. So we would write that as 3 times 1 less than the figure number. I'll use n for the figure number. I could use f. Would you like f instead for figure? I heard a yes. We could use f instead for the figure number, minus 1, and then we always had to add the 1 in the end. So this is the formula that you guys used for the 10 and the 100. When you did 3 times 99, you did 3 times 1 less than the figure plus 1. And now we can use our algebra skills. What could you do with the 3 outside of the brackets if you want? You could use the distributive property. And you would get S equals 3F minus 3 plus 1. Are any of those like terms? The minus 3 and the 1. You could combine those together. What is minus 3 plus 1? 2. Minus 2. So we did 3 times 99 plus 1 to get 298 on our calculator. If I use this formula, if I want to find the 100th one, I would use, all these things we've learned so far. Use substitution for 100 in there. What's 3 times 100? Mental math. 300 minus 2. Yeah. Happy face. So we notice a pattern. We notice how much we're adding by each time. We fill in the table. And we can create an equation. So what we just did there was this next part, creating an equation. So we can fill in some of the things that we did already. So here, 1, 2, 3, 4, 5. We know that it was 1 square, 4 squares, 7 squares, 10 squares, 13 squares. And again, we noticed the linear pattern was that we're adding by 3 each time. So it says to figure out the formula, multiply the figure number by the increase in squares. So we're going up by 3s each time. So we start off by saying the number of squares is 3 times the figure number, because we're going up by 3s. Check if that works. If I do 3 times 1, do I get 1? No. 3 times 2, is that 4? No. Is 3 times 3 7? No. I'm just noticing something, that if I use 3 times f, it's always 2 above the answer. What's 3 times 5? 15. The answer was 13. What's 3 times 4? 12. The answer is 10. What's 3 times 3? 9. The answer is 7. What would I have to do to adjust the equation if it was always 2 above? Minus 2. So then I can create my formula then would be 3 times the figure number minus 2. How many squares would be in figure 7? Well, I could just keep my chart going. That would be one way that I could figure out figure 7. But now that I have a formula, I could use substitution for f we know is now figure 7. Remember substitution, we put brackets, enter in the 7. What is 3 times 7?
20.
Close. 21. And then you subtract 2?
Then that's
19. If I would have kept the pattern going, 6 and 16, 7 and 19, yes, it works out. Beautiful.
What figure would have 16 squares? You know what figure would have 16
Excuse me. What figure would have 16 squares? Well, we have our chart. We can see it from our chart that it's 16. But we could also use substitution because now we would know that S is 16. So in our formula, we could substitute 16 for the S and we'd have 3F minus 2. Now, we haven't done our solving equations unit yet, but you have done solving equations in grade 8. So this is a little bit of review. In solving equations, you have 3 times something minus 2 is equal to 16. What would the 3 times something equal? What would have to be here if you subtracted 2 to get 16? No, I don't want that. I just want this whole thing. Something minus 2 is 16. Let me write it this way. Something minus 2 equals 16. What's in the box? 18. Something minus 2 is 16. In the box is 18. One of the things you might have learned in grade 8 is that if this equation is equal, you could add 2 to this side and add 2 to this side, making the 3F by itself, and 16 plus 2 is 18. Then this question is really asking 3 times something equals 18. What's the something? 6. The something is 6. So we can say that F is equal to figure 6. Okay. I want you to draw a design for this next pattern. If you don't have a red pen, a green pen, and a blue pen, instead of drawing a bead that is red, make an R for red. Make a G for green. Make a B for blue. That's if you don't have different colors. If you have different colors, you can make a red one with a red circle, a green one with a green circle, and a blue one with a blue circle. Good idea. There we go. A bead design for a necklace has an arc shape. So you have to know what an arc looks like.
I know what an arc looks like.
Row 1 has 7 beads. Row 2 has 5 additional beads than row 1. So how many How many beads in row 2? It has 7 plus 5? 12. Row 3 has another 5 additional beads than the previous row. It has 17. What happened on this whole page, Luke? You just didn't do it?
How are you supposed to do it with an art when you have to use 5? Because then it's not even on all sides. Of course you would still have those beads. Oh.
That would be the first one. What would the second one look like? You would add after the red, so you might use, oh, then it's green. How many green are going to be in the second one? You add 5 more. Or sorry, you started, how many were in the first one? 7. I only did 5. I'll draw it better. 1, 2. There's 7. How many are going to be in the next one? 5 more. I should make that in, maybe I'll center this.
Oh, okay.
Okay. Okay, next one's going to have how many if it's 5 more than the last one? 12. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're green ones. Crap. I know, they're supposed to be green. I'll just color over top of them in green. There we go. Thank you for noticing. This is actually quite fun to color over top of them. There they are. And how many are going to be in the last row? 17. And what color are these so I don't screw up? Blue. So if I put 1 here, I need to put 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's so pretty. And I want to just change this in here. Row number and how many beads are in that row. In row number 1 was the red one. How many beads were there? 7. In row number 2, the green one, how many beads were there? 12. And in row number 3, the blue one, how many beads were there? 17. Add. And what's the pattern that we're doing each time?
3. What? Oh.
5.
So without drawing the fourth one, how many would there be in the fourth one?
None.
22.
I'm having deja vu right now.
So we're adding 5 each time. If we're adding 5 each time, and we want to know the row number, or so can I use R for row number and B for beads? We would start by taking our row number and multiplying it by 5. How close does that get us to our equation? If you do 5 times 1, what do you get? 5. 5 times 2, you get 10. So in order to make it work, what would you need to do? Duncan says you would need to add 2. Does that make sense?
Yes.
No, it does not make sense.
If you're going by 5s each time, that's all right. If you're going by 5s each time, you take your row number and multiply it by 5, and you check how close it is. What's 5 times 4? 20. And I need to get 22. So what do I need to do? Add 2 more. Does it make sense now? Okay. How many beads are there in, again, I'm just going to change the wording here a little bit.
32.
No, you haven't, Sharon. I've been 13. You haven't taken care of that. And if you haven't, then you'll probably be in jail.
How many beads would there be in row 6?
32.
32. How did you figure that out?
5 times 6 plus 2.
So you're taking, our formula says that our number of beads is 5 times however many rows we have plus 2. 5 times 6 plus 2. 5 times 6 is 30, so 32 beads in row 6. In what row, again, my wording, I don't like it here. Change this to, in what row are there 52 beads? So now this is a solving equations 1. You know that the beads are 52. So 52 equals 5R plus 2. You have to see if you can figure out what number would go for R. That makes that work.